I hope by undertaking research focusing in sustainable development, we will be able to create change as part of a continuous improvement process.
Recognize the work of healthcare and life science scientists and organizations who contribute to innovative healthcare solutions.
I hope participants will continue their efforts in showcasing their hard work, find a product, and meet potential partners.
We are growing too fast. We walk fast. We eat fast. Though we have 24 hours in a day, somehow we share the same feelings. Time is passing so fast. We don't have enough time for ourselves until busy is the new norm in our life. But if you can turn back the clock, what good shall you do today? Let's put life back. We need the past to enlighten the present and the future. We need education. Through education, it reconnects you with the purpose of life. Reconnect with family and people. Reconnect with nature and habitat. Reconnect with unity and harmony. Reconnect with spirituality and peace.
اقرأ باسم ربك الذي خلق.
Reconnect with good health and well-being. To create balance, UITM nurtures Buddhi in education and embraced it as values in life. A concept of social relationships. A philosophy and culture of politeness, reasoning and wisdom among Malaysians. UITM upholds Buddhi for sustainable community. Education reconnects you with the universe. Reconnect your world with UITM.
In the quest to search for knowledge and insights, diving deep for ideas to gain prominence, be they the scientists, teachers, accountants, entrepreneurs, engineers, artists, managers, lifesavers, mothers and fathers. Let us be a trusted companion, your preferred high-flying institution, as we achieve excellence holistically. Because we believe in nurturing our future talents, we endure sowing the seeds for a sustainable tomorrow. We harness your capabilities. We take steps and stances to broaden our knowledge and experience. We want to be the champion to uphold mankind's universal values, to encourage a deeper understanding of sustainability. We dare to be different. We instill values. We cherish the diversity, where science and arts complement each other. We go boldly. Set the scene. Steal the show. Think out of the box and set our sights. Walk far and wide. We dedicate ourselves to all our passion, to nurture the courage in all of us. We lead.
UCSI University has come a long way since 1986 as a Praxis University. Today, UCSI is ranked at the top 300 university in the world, rising steadily every year, reaching the rank of 284 in the year 2023. In the same year, UCSI became the only university in the world to receive the QS Recognition for Improvement Award, having improved by the most ranks in average. UCSI programs are ranked among the world's best in music and performing arts, hospitality, engineering, business management, art and design, social sciences, and medicine. As a Praxis University, our students are exposed to a wide learning experience. Thousands of corporate partners offer internship and work exposure to UCSI every year, enabling our students to apply what they learned in the classrooms to be practiced at the workplace. They give the students opportunities to work and learn. This resulted in our graduates attaining 100% employability score in all our programs. One of the hallmarks of being a UCSI student is the research attachment opportunity at world-leading universities at the undergraduate level, enabling them to publicize remarkable papers at the world stage. opportunity to study abroad, whether for a year or two, or for a short term of a few months, prepare our students the global outlook that the world needs today. Preparing as leaders for tomorrow. The students are exposed to real leaders today, from academics and economics, to social concern and topics on sustainability. Our students are set for the challenges today and the future. UCSI offers the largest fields of study in a Malaysian private university, whether in championing healthcare and medicine and pharmacy, impacting research and discoveries in applied sciences, applying skills and intelligence in engineering, influencing communication in social sciences, igniting the passion and creativity in arts and design, setting the global pace in hospitality and tourism, transforming architecture and built environment, celebrating with music and performance, excelling in the changing demand of the business world, or digitizing the world in computing and innovation. UCSI continues to serve with scholarships, producing tens of thousands of practitioners and young leaders from more than 110 nationalities. Beside its current main campus in Kuala Lumpur, and other campuses in Kuching and Spring Hill, UCSI has earmarked its Kuala Lumpur campus to expand as an edu city with 35,000 student capacity with various state-of-the-art facilities. Our students are the real stars of UCSI. They achieve and excel in the national and international stage. Driven with the passion to contribute, they prove their quality, participating in various events and attaining many successes. UCSI enables them to make the mark for themselves, build their own reputation, and create a brand for themselves to face the exciting world ahead of them. Every year, our medical students advance their undergraduate medical research at the Harvard Medical School. Others made the engineering impact at the Imperial College London, at Queensland, Australia, and Tsinghua, China. While some set their pharmaceutical legacy at University of Chicago and British Columbia. These are some of our students who have benefited from our Star Trek to the world's best universities. The world is changing, and they are at the forefront. The needs are evolving, we continuously confront. UCSI, a Praxis University.
Ladies and gentlemen, welcome to our knowledge sharing session. We hope you'll enjoy the next webinar. Thank you for joining us.
Ladies and gentlemen, we thank you, Exo Technology, for presentation of the Sarawak Sawas Solar Aru project. So we has been sitting in the room for quite some time, whole day in the room. We just managed to fly 1,000 over kilometer to Dalat, Pintulu, Bario. I see the Benta house, the long house was very nice. So now we will invite our panelists, the project manager, Mr. Jeffrey Jong, and the two project engineer, Mr. Chia Sing Wei and Satila Wantilingam, to come to this Q&A session, right? So let me see. Oops, I have to look at the other. Am I right to say so? I can't see. Can I see any? Is there any coming in or is in this chat? There's nothing at the moment. So I have some question. Okay, let me ask a question first. So I see so many interesting and advancing technology being put in Sarawak for those rural kampung folks. So after the treatment of RO or UF, do they still require chlorine disinfection as required by the MOH or not? In that sense.
Okay. Actually, this is in theory, certain chlorine residue is required for if we're following the MOH specification for this drinking water specs, right? So in between, usually it's in between about 0.5 to not more than 2 ppm. But since the tanks, everything is quite near to their house, so probably a maintenance, the minimum maintenance of this 0.5 to 1 ppm is should be good enough for this for them to drink. So, and what we know is after our old system, usually it's zero. There's no chlorine after this our treatment. For rural area, there's one main challenge is usually the main challenge is this logistic issue and chemical handling. So because of this, we need to compromise a certain of this arrangement, this specification arrangement with these the local users. So we provide them, we provide a system that capable to treat the water up to a drinking water standard, but without the chlorine. So what they use, the local community, what they will do is usually from their house, they get the water, they will boil it to disinfect themselves. Because handling chlorine is definitely will have some will give them some impact on the first is the logistics and the operator who is going to handle it. So they're not very clean. Sometimes not very clean, but basically they will have to boil the water. So and except this barrier water treatment plant in Barrio, which is a slightly bigger plant, so it's about 1.5 mld. So the plant is for the plant we do dose chlorine, we dose hypochlorite to make sure that the treated water itself it has a minimum chlorine residuals about 0.5 to 1 ppm, so that the stored water after some time is still safe to drink. Okay, but for small systems in rural area, those like long houses, most of them we don't do those any chlorine, and users they are all get the water and they will boil it, and they after that they consume.
Okay, I think like what you say, after the RO, maybe there's not much thing there. This is, it's like more to the Ministry of Health requirement, worried that there's so-called, there's some bacteria came into the system from the system. I think so, isn't it, Mr. Chia?
Yes, yes. Okay. Regarding that issue, that is actually part of this system maintenance issue. Okay, for part of the system maintenance issue, yes, we do we dose some chlorine for disinfection to make sure that in between the membrane, the membrane filters itself, it doesn't have any contaminations. So whenever we go in, once a month we go in to inspect the system to check to have some some minor servicing. We will dose some minor chlorine for mainly just to maintain the systems to ensure that it doesn't come the bacteria doesn't stays there. Yeah, some minor disinfections. That's the only point that's the only time that we dose chlorine for the system maintenance.
Okay, thank you, Mr. Chia. There's a question from Outlet Water. They are asking about are the solar Sarawak project hosted by Exo Technology still ongoing? Is it still some more coming? I think the meaning is like this. They are asking whether there's still some more coming, or in total how many has been done, and how many is coming to be done. Maybe Jeffrey, you can answer this question.
Okay. Actually, there are quite a few SAWAs still being implemented in Sarawak by our state government. I heard that there are 12 packages ongoing currently right now this year. So some of them without any electricity supply, so they will be using solar system. Whereas some are mixing using hybrid system, which is solar and genset. So some kampongs, they are quite fortunate, which they are able to enjoy this what we call rural electricity supply. So with those electrical supplies, they will not be using any solar system for the SAWA's package plant.
So in total, how many project Exo has been completed, and how many are upcoming?
Okay, so far for SAWA's, Exo has done 3 SAWA's system.
Is there any more upcoming?
No, not by Exo, by other contractors.
Okay, understand. So I understood that the SAWAs mean to fulfill the what they call the supply to this rural area up to 100% until 2025. Is it correct? Or I'm not so sure about the timing.
Sorry, can you repeat?
The SAWAs mean to supply to the rural 100%. What is the timeline? Until which year? 2000 what? 2030 or 2025 or?
According to Ministry of Utilities, JBAP, Jabatan Bekalan Air Luar Bandar objectives, the aim is to have 100% water coverage by 2025. So that's why our state government is taking quite a big step, taking some initiatives to have this SAWA system so that the rural folks are able to enjoy clean and filtered system. Clean and filtered water.
So good. That's very good. I feel a bit jealous because the rural can even enjoy RO water. Membrane water, and then we are here, we are conventional, our water is not that good. So I think this fantastic so-called high-tech system may have some I'm not so sure. How do you all maybe Satila can help to answer this question. How do you all make combination? Because I understood that this system will be run by those kampong folks. So how Exo, your maintenance team works together with the kampong folks to have a sustainable maintenance to make sure the thing run continuously?
This includes a lot of working together as a team. We need the people from those areas to agree to work with us and also to understand how to maintain the system when we are not around. So we do have a session where we train out the people and whoever will be guarding the whole system, and that helps them to continuously keep the system going on.
So far, is there any major problem you encounter and how you solve it?
Major problem, maybe Mr. Chia or Jeff can answer that one.
Maybe I just add on some points about these issues. So SARS project is actually this is an initiate for this like what you Mr. Eddie say. The target is to ensure that all the Sarakians even in the rural areas, in places that is very far reach away from this city area, they have the ability to enjoy the clean water. So there's so many places, actually they are quite scattered around, and places like this actually they have one issue is the logistic. The mainly is the logistic issues. Other than that, it's not a big problem. The main problem is the logistics. So what we usually face is like bring equipment going in and bringing in tools, machineries for the construction. That's the main challenge that we face so far. Other than that, in operating the plants, of course, thanks to the development of the technologies, I mean, our water treatment systems is gradually improving, and our solar plants technology is gradually improving. The efficiency is getting higher and higher. Operating in these equipments, these systems is getting easier and easier. We just need certain important parameters that which we need to monitor. Then as long as everything is according to our manuals, the parameters, the readings is not off chart. The local communities they have not much issues in operating it. So we make it as simple as possible. They just need to monitor a few things, and then they can just run it. A couple of buttons, then they just run, then they get clean water. So, like what you say is the main issue is logistic communications. So certain areas, the communication line is not as strong as what we enjoy in the city area. So they might need to travel a bit further to contact us if they have any issues. So that's the only challenge part. I mean, in between, when we communicate with them, and sometimes the line breaks, everything. So that's the only that is the main challenge that we face. But so far we are quite lucky. Even with all these restrictions, we still manage to to work together with them, and we still manage to run the plants. All the locals, they still manage to have this clean water, without any issue, much big problems.
Good.
Yeah.
This is very good, Yeah, even in the rural area, people with lower education, but they manage to run such a high-tech system successfully.
Yes.
There's a question coming from the floor. Somebody is asking why Sarawak didn't consider groundwater for rural area. Maybe you all can try to answer.
Okay.
Wide open question.
So groundwater, yes, we do consider groundwater, but groundwater actually is quite it's very specific, subjective to the area that you're going to be using it, because different area they have a different groundwater quality, water quality. Certain areas they have a very high nutrition, high minerals, which if in order to treat the groundwaters, we might need a more sophisticated equipments. Like if there's certain areas that they have a very high mineral, like high iron, high calcium, very high hardness. So basically conventional methods is a bit maybe a bit hard for the operators, and we might need to implement certain system like ozone for the removal of certain these extra minerals, blower systems, UV systems, which eventually will going to use up more electricity. So the thing is, we don't forget is these rural areas, they at first they already have this some difficulties in getting the electrical power. Like what Mr. Jeffrey said mentioned earlier, some areas they are very lucky, they can enjoy this a very stable power source using this from the local power supply power plant. Okay, but some areas they don't have such luxuries. Okay, so everything mostly you have to depends on these generator sets, depends on solar powers. So when this consideration comes in, we need to design a treatment plants that is low energy consumption, and which still can provide the clean water. So these are the considerations that make us think makes the local governments think that groundwater might not be suitable. But certain areas, yes, we still can use. If we manage to get a very clean groundwater, of course that will be our first priority. But certain areas which we cannot get the groundwater with a satisfied raw water quality, then we will have to go for river water. Yeah, that's river water. That's the main concerns.
Yeah. So in short, that means groundwater, water quality can be even worse in using energy, and can be even worse, in using even high-tech technologies such as ozone and UV and so on, right?
Yep, correct.
Correct. Yeah. So that is why, in this case, I think the government is using solar RO. There's another question from the ground. They're asking, solar RO versus rainwater harvesting system. In your opinion, which is more economical for the rural area? I mean, if we can treat the harvested rainwater to potable water quality standard. So
yes, yeah, of course.
how do you look at it?
In layman terms, of course, harvested rainwater is sounds more economical, but we shouldn't forget that even though in Malaysia, especially Sarawak is a rainforest country. In Malaysia is a rainforest country, and Sarawak is there are a lot of forests, but we still have drought seasons. So when drought seasons kick in, it's impossible to have this rainwater. It is almost impossible to have this harvest rainwater. Okay, it can be lasted for 2-3 weeks without any rains. Okay, it happens before. So in previously we do have certain areas, we do have this harvested rainwater as a storage water tank as a backup, and with this backup water, and then we can use we can use this kind of water and then go into our RO systems, which give them a better water quality instead of just typical rainwater, which and then they still have to use a simple filter, some filtration to clean it and to boil it. So we get the water from the rainwater certain period of time when there's an extra rainwater. So this rainwater can divert to our systems, and we treat it and then distribute it to the locals. So they have a dual source. But yeah, rainwater sounds economical, but it is not a very stable source. Unfortunately, that's the case.
Yeah, I remember during the Gawai, in May, end of May or something like that. That is the so-called drought period, and everybody balik kampung in Sarawak, there's no water.
Yeah.
So this will solve all the problem. I think it's about 6 o'clock now. I will be making another last question. This question from the ground. The question is to Mr. Jeffrey Jong. The question asks, what is the life cycle cost per meter cube for the solar RO system? Jeffrey? Can you hear me, Jeffrey?
Yes, I can hear you.
Yeah. So life cycle cost means you are including the operating cost and the capex cost and the replacement of capex, including, you know, the project cost itself, you know, something like that. You know, you could try. Maybe you have, your company have not or not really work out this figure. Do you have some figure, at least the operating cost, and then, you know, for like how much for how many MLD, something like that?
Okay, I don't have the actual cost for per meter cube. Okay, but usually for Exxon, we did have operation and maintenance for our SAWA system. Okay, so what I can say is we are charging government for operation itself is around 15,000 per month. This is of course including operators and also some consumable items. So all in all, I could say is actually quite depending on the plant capacity as well. There is quite subjective for this cost. This is what I'm able to explain.
So do you have some idea, a project like, you know, example of the project like, you know, 1.5 MLD, how much it will cost for project?
For 1.5 MLD, I have no idea for that. But for SAWAS, okay, I am looking after one SAWAS system in Bintulu, which is 0.1 MLD. Okay, the operation cost that we charge is about 50,000 per month.
So I'm not sure whether, you know, but since we do not have the life cycle cost now, maybe the participant who asked the question can forward the question to this MIWC or forward to me, and then I can forward to Exor, you know, to answer this question. So I believe, like yesterday, we have a technical tour talking about recycled water from the sewage. So that one will cost, you know, life cycle cost will cost RM2.20+. You know, that one, you know, RM2 operating cost, that not including the distribution cost, is something like that, you know. But this one, because of, I think because of the SAWA, so this RO is to the rural area, the plant are very small, there is not much economic scale. You know, maybe the government is not looking at what is the cost efficiency. They are looking at the total solution for supplying the water there. Right, I think so. Yeah. So I think we have 5 minutes past the program time. So with that, you know, I think I thank everybody. I thank the panelists and everybody for participating in this session. Thank you very much.